Let's try this one, okay? I don't know. I think my brain is partially fried and I can't keep up with. Find an expression. So we are not going to find an exact solution, but we're going to find an expression for the area. Of course, under the graph of, this is a different function. It's f of x equals e to the negative x. And also the interval is on 0 to 2, not 0 to 1. Okay? Notice that I didn't tell you a right-hand sum, left-hand sum, or what, or how many subintervals. That's it. Now, by the way, one thing we need to be clear, really, if we are looking at what we've done so far, for instance, this example and the previous example, we are really capturing the area between the graph of the function and the x-axis over an interval. Okay? So I just say and write under the graph, but really what it implies is the area captured between the curve itself and the x-axis. All right, so let's illustrate first this function. At x equals 0, e to the 0 is 1. Okay? And at x equals 1, e to the negative 1, do you know what's e to the negative 1, by the way? 1 over e? It's an important value, 0.37. It's used a lot in, actually in radiation oncology, which my son is one. It's a quantity that important in applying radiation in the therapy of cancer patients. Also, this half-life business is also very useful if you get into radiation. Anyway, so we start at 1 when x equals 0, we go to 0.37 when x equals 1, and then when x equals 2, we have e to the negative 2. This is an exponentially decaying function. So we are looking at the area in this region, and since we are not told how many subdivisions, we're going to say, okay, we're going to start with, this is x sub 0, so then here's the first division, so it's x sub 1, the second one would be x sub 2, and so on, x sub 3, and x equals 2 is really x sub n, and the one before will be x sub n minus 1. Okay? The first thing we need to establish is delta x, and we're going to use the fact that x sub 0 equals 0, x sub n equals 2, and therefore delta x, which is always x sub n minus x sub 0 if divided by n, if the intervals are equally spaced, will be 2 minus 0 divided by n, or 2 over n. So you see the resemblance of what we did before, except now we have two over n instead of 1 over n. Next, what we did before is we evaluated x sub 1, x sub 2, x sub 3, and we found the pattern, and we wrote a general expression for x sub 1, x sub I. So we'll do the same. So x sub 1 is x sub 0 plus delta x. Of course, x sub 0 is 0, and delta x is 2 over n, so x sub 1 is 2 over n. X sub 2 is x sub 1 plus delta x, so it's x sub 1 is 2 over n, delta x is also 2 over n, so we have 4 over n. By now you already know what will be the pattern, but let's do take one more step. X sub 3 is x sub 2 plus delta x, or 4 over n plus 2 over n, and it's 6 over n. So what is x sub I? I'm asking you guys. Do you see the pattern? 2, 4, 6. For 1, 2, 3. So for I, what do we have? 2i over n. And to check, what is x sub n? Well, it will be 2n over n, or simply 2. So again, you check. Okay? So x sub I is 2i over n. And this is what we really were after. And now we're going to say the following, that f of x sub I will be e to the negative x sub I, or e to the negative 2i over n, like so. Okay? So now we are ready to do r sub n. Again, I'm choosing r sub n. I can choose L sub n, I can choose M sub n. At this point, it won't matter because in order to find the general expression, I need to take the limit. And the limit, don't care if you do right-hand sum and left-hand sum or midpoint. I'll talk some more about it tomorrow. But here it is. It will be the summation. It will be sigma, I goes from 1 to n, of f of x sub I times delta x. So we're going to write sigma I goes from 1 to n of e to the negative 2i over n times 2 over n, which is delta x. And again, as before, 2 over n does not play a role. As far as the summation is concerned, it's a constant. N is a fixed number. So we're going to pull it up front and say this is 2 over n times the sigma from 1 to n of e to the negative 2i over n. Okay, but this is the right-hand sum. What will be the actual an expression for the area? Well, the area will be the limit as n goes to infinity of 2 over n times the sum from 1 to n of e to the negative 2i over n. Okay, and this is the answer. This is the expression that we were asked to provide. Now, turn out that this sum is a finite sum because as n goes to infinity, 2i over infinity is 0, so the last term will be e to the negative 0, which is 1. So it's a finite sum. It's what we call a converging series. You learn a little bit more about it in Calc 2. So this value is a finite value. Okay? For instance, for homework, you can evaluate or estimate. This is an exact, but you can estimate at home the area if you substitute n with 10. So estimate the area using n equals 10 intervals. Okay. Again, I would use Excel spreadsheet. Final notes. Final note, actually, one note about this thing.